I'm Allan, and a member of the storage SIG of the Computer History Museum. And we're here today for the purpose of doing an oral history of Jim Morehouse. Now, Jim has quite a time in the industry and a whole bunch of patents. A couple of them are really primary patents in the development of the disk industry. And Bruno Marchon is also a member of the SIG, and he has a real interest in several of the things that you patented, Jim. So we'll be delving into your memories on how that worked out for you.
Okay.
Now, I guess the thing is that let's go back to when you were at school, where you went to school, where you grew up, and how you eventually wound up in the disk industry.
Okay. Well, I was living in, I was born in Washington, D.C., but then my father headed to the West Coast after the Second World War. And after, he tried a few things, kind of like startups, but back then, not 1950, it was not a big thing to do. But he ended up then working for Crown Zellerbach building paper mills. And we moved around a bit on the West Coast and ended up in San Rafael, where I finished high school. And so it was fairly easy to just jump across the bay to Berkeley. And so I entered Berkeley around 1961 or two. And after, I don't know, four or 5 years, I got a master's degree. And then I had a choice to make, and I was the last age group that got 5 years of graduate school deferment. So I could choose to stay in graduate school or go to Vietnam, and I chose graduate school. I never considered myself to be an intellectual, but I'm more of a get it done and tinkerer and designer and all. But so I I stayed in school and ended up getting a PhD in mechanical engineering. So I had a bachelor's, master's, and PhD all from Berkeley. And I had minors in civil engineering structures, which was really the shaking of buildings. And also I had a minor in numerical analysis, which I barely squeaked through. I'm not much of a mathematician. So then I graduated right at the big aerospace bust. In '69, there were engineers pumping gas and all. So I built kayaks, fiberglass kayaks for a while, and then I believe that I think I was at some kind of a party or something, and I met a fellow named Dave Brown, who was one of the founders of Quantum. Does that ring a bell?
Yes, it does.
Okay. And he Memorex was not hiring at the time, but he thought that I would be an addition to their technical staff, and he managed to get me in for an interview, and they did hire me. And I started out working. Oh yeah, that was one other name. Yeah, Juggy Tandon.
Oh yes, definitely.
Yeah, he was there, and he was working on a floppy disk then, and I worked on that a little bit, and then they had some vibration problems, and that was a main part of my education was vibration. In mechanical engineering, it was design and vibration. So I I started to look at some vibration problems, and the Terry Johnson was the servo engineer, and he had a vibration problem in the tack circuit, and which I eventually figured out and solved with a material change. And right across the hall from me was Roy Applequist, who became a very good friend of mine, and I believe that I basically learned how to be an engineer from him. College was a good foundation, but Roy was the most practical engineer I'd ever run into, and he and I got along just great. The other people that were there at Memorex, besides Roy and Terry, Finus Connor was there. He started out as a printed circuit board designer. I think he was doing that when I was there, but then he got onto Al Shugart's staff as a marketing guy. And of course, as Al was there, and I met Al a few times, and over the years I got to know him a little better. Syed Iftikhar was one of my fellow engineers, and also worked with Norm Dion some, and Roy and I did, and in fact there's a, well, to me it's a famous photograph, but there's a picture that shows someone's hand pouring a Dixie cup full of brown paint on a spinning disc. Yeah. Are you familiar with it?
Bill Carlson, I think, took that.
Well, I think that the person's hand is Norm Dion's.
Okay.
That was my understanding. But anyway, so I was working with some of the guys that worked on some of the on the Ramac, and at the time Memorex was shipping a 2314, and we were working on a 3330 drive, and there were some vibration problems that were delaying the shipment of that 3330, and I built up a lab doing let's see, interferometric dynamic holographic interferometry. So yeah. So we'd shake the guts of the drive, start out, make a reference, a hologram of it, then we'd excite it, and stroboscopically just tune out all the shaking, and could look at the actual displacement at a particular frequency. It didn't end up solving the problem, but it gave us a lot of insight into other pieces of the hardware. Let's see. So then after a couple of years there, let's see, Roy and Terry Johnson went over to a little startup called Disk Systems Corporation, and Ivan Pasha had sold this idea of the Superdisk to Jesse Ueda.
Yeah, I worked with Ivan at ISS.
You were, okay, and and Ivan and I had became friends, although he was sort of always on the outside there at Disk Systems. But so I worked on that Superdisk for I don't know, a year or two, and I think that Dave Cordano joined that group along the way. So, but the management was wasn't getting along very well with Jesse Ueda. And so Jesse finally said, you know, so, cut it off. And so I believe the only people that moved back to Colorado were Terry Johnson and Dave Cordano. And I was not going to go, but at the last minute, there was one of the fellows I'd worked with from Colorado talked me into coming out and visiting StorageTek, which I did. And I'd actually accepted a job in LA working on a word processor. And but I got to Colorado and I looked up and down the Front Range and I said, how can I do LA to my family? You know, when and so I thought it was something less than it wasn't as big an opportunity for my career, but it was the right move for my family. And by then I had by the time I got to Colorado, I had 2 children and a lovely wife, of course. And so I worked at storage for several years. And let's see. I started out, I think one of the first things I did, I solved a vibration problem on a capstan motor they had. And I know someone came by my office one time and said, how did you come up with this with this great invention? And I said, well, I did a layout. I thought it was fairly straightforward, actually. So I was there for some time, and one of the VPs, who was a friend of mine, pointed out in slightly more graphic terms why I was never going to be a VP there. And I thanked him for his input and shortly thereafter quit. And started Amcodyne. And Dick Latt and I started out in my garage, and we played around with dynamic head loading. And I'd come across this when I was talking to somebody from one of the head companies. I think it was like one of the ones out there in California, out on the coast. And we'd experienced problem with when we were trying to do flying height testing with heads on a glass disc. The head would just love to stick to the glass disc and rip it off. So, I was discussing this problem with this engineer from the head company. He said, "Oh, well, what we do is we just drop it on the disc while it's spinning." And I had never been impressed with contact start stop, because there was so much snake oil and black magic involved. And in this person's statement, "Oh, we just drop it on the disc and it works fine." And that got me thinking, and that's when I got enamored with dynamic head loading, which of course the 3330 and the 2314 used, but the contact start stop had been introduced by IBM by then. So started Amcodyne, and it was an 8-inch fixed removable drive, a linear actuator, and we were planning on competing with the LARC, with CDC LARC 8-inch fixed removable. Unfortunately, it was end of the line for that product.
That was the Arapaho, right?
I'm sorry?
That was the Arapaho.
What, the product name?
Yeah.
Oh, it could be. I don't recall.
The fixed drive was the Comanche. You guys were into Indians.
Okay, well, we've got a Arapaho road out here, and the Arapaho Indians were around here, but I didn't recall the product names. So Dick Latt and I started it, and then we got Dave Cordano to join us, and we built the product, but the market just wasn't there. It was drying up. So as it was kind of going down to, winding down, I went and started PrairieTek, and that was with Terry Johnson backing us, and he had made a pile of money off of Connor peripherals, and so he put some money in, and we went out on his ranch, and he had a spare building, and we worked there for a year or so, and then moved into town, and that was a rotary actuator, and I figured out how to do dynamic head loading with it. And let's see, Steve Volk joined us along the way as a marketing guy. And around that time, Professor Bougie at Berkeley he was doing some measurements on heads landing on a disk, and he showed exactly why this dynamic head loading was working so well, because the head started to fly a long ways away from the disk, and it kind of got itself all corrected and lined up and landed very nicely, and he showed that very graphically. Around that time, I was very enamored with dynamic head loading, and explained it at some length to an engineer. I think it was Moon at Quantum. Well, they went off and patented it, and before we could, and so we ended up having to kind of dance around their patent. But then after a year or so, we did a cross licensing agreement with Quantum, and got back on track with the configuration. But the PrairieTek, the first product was not so good. The second one I thought was a real dynamite design, and but by then Terry Johnson had brought in some management from HP Boise, and they were ineffective in executing anything. They couldn't get product out. They couldn't get manufacturing going. Just the whole thing just kind of died. And right at the end of that, I went to they were auctioning off the patent portfolio at PrairieTek, and I went to a federal courthouse in Denver to witness this, and the Connor Peripherals bought the patent portfolio from PrairieTek for $17 million in cash. Yeah. And And then there were other considerations, which there were, that they were taking care of some, I forget, some other obligations that actually made the whole package worth about, I don't know, between 20 and $30 million, of which I got nothing. Even though my name was on just about every patent. So Steve Volk and I went and started Integral Peripherals. And Steve had some contacts in Taiwan, and we got money out of Taiwan and started working on the 1.8 inch. And by the way, starting at StorageTek was where John Blagala and I first got together. But then I had dragged him along with me to Amcodyne, PrairieTek, and then Integral. And same thing for the servo engineer. Did you know Tom Andrews at ISS?
No, I did not.
Okay. Who was the servo guy there? Was
his name is Dick Oliver. I think it might have been Dick Oliver for a while.
Yeah, I think that's the one that then Tom worked under him.
Okay.
And but Tom was just a superb servo engineer. And so let's see. Then in Integral, we got to the point where IBM actually designed our drive into IBM Japan designed the drive into a little, something like an iPad.
Yeah.
And we thought we had it made, and then they did a test market, and shipped a bunch of them out, and it was not well received, and that dried up. So we started selling patent licenses and sort of how to do dynamic head loading, and raised a ton of money that way, and kept going for a few more years, and then it was all over. After I left Integral, actually sometime before that, I was an expert witness in a trade secret trial in Minnesota. That had to do with a tape drive motor, and that's while I was at StorageTek, I guess. And then after I retired from Integral, I actually was an expert witness in a Seagate versus versus Cornice.
Yeah.
There was, Seagate was trying to put Cornice out of business, and Cornice had been started by Kevin McGinnis, who came from HP Boise, and I worked about a year and a half on that patent infringement case. And it was interesting that at the end, Cornice had raised several $1 million to pay for the lawsuit, and I heard a year or two after the thing was all over, the lead attorney for the Weil Gotshal said that Cornice had stiffed them for $5 million worth of legal fees, which that was kind of Kevin's modus operandi. So that's a little rundown on my my work history, you mentioned two patents that you were interested in, and the one, let's see, the 785. That was kind of my first attempt, or our first attempt at a 2.5-inch drive with dynamic head loading. And then the other one, the other patent that you mentioned, kind of it was it features this soft rubber cover. It has, which I thought was, that never was a real big seller, but I thought we did several things that were fairly important. Of course, had dynamic head loading on it, and using a little lifter on the tip of the suspension rather than back in the middle of it. It also had, well, I think actually even from early on, Tom Andrews, the servo guy, had worked out a way of using the back EMF from the spin motor to unload the heads if you lost power. You could unload it, with a command, but the thing would unload and get the heads off the disk with loss of power, which I thought was a pretty important thing. And I've even heard, I think that they now do things where they sense a free fall and they unload the heads before it hits the ground. But the couple other things that I thought were very important contributions. One was, and my recollection is I will tell you my recollection, and it may or may not be totally accurate, but I believe that one time I was talking with Tom Andrews, and I asked him, well, how close can you follow run out? And he said, 90%. And I said, okay. I said, but run out is predictable. And I said, so if you knew the amplitude and phase of the run out ahead time, how closely could you follow the track? And he said, and he laughed and said, 100%. And I said, well, why don't we work on that? And he went off and he came up with run out compensation. And he did a fast Fourier transform of the signal and pulled out and he actually did it for the first, second, and third harmonics, all three of them. And I think that was a really important step forward in the servo. Then we'd made a number of drives and shipped them to Japan, and we're trying to sell them in various places. And I think we had one. I think it was at Casio. I'm not sure. I forget which Japanese laptop maker, but the engineer there was playing around with our drive, and he was banging it on his palm, which would be kind of hard to do if it was built into a laptop. But anyway, he was doing it, and he managed to get the heads to the heads were held in a little detent. He managed to put enough rotational acceleration into it to launch the heads out on the disk when the disks were not spinning. And he presented this as a problem, and So I went back and thought about it for a while, and I thought about your the seatbelt restraint in a car. Whenever you hit a little bump, you can't pull the seatbelt out. So I thought we need something like that, and I came up with this inertial lock, the eye lock we called it, and it would, under one of these rotational shocks, it would deploy, it would rotate in, hook on the actuator, and keep it from going out on the disk, and then get out of the way again, so the drive could go ahead and operate. So those I thought were some of the more important inventions, and I did end up with something like, I don't know, over 40 patents in my name. Almost all of them in disk drives. I think there was one in tape drives, one or two in tape drives, but
Well, I got to say to you that when Connor and Alps together bought the package from Integral Peripherals, it was a bidding war. You had everybody going after them. And the interesting thing is that the money kept rising. And the more it rose, the more somebody else wanted it. So you had this bidding war of anxiety going on in the federal court. So you probably saw the players involved, WD, Seagate, all in there, huh?
Yeah, although the Connor was my recollection is that Connor was way ahead of anybody else, and their intention was to take that portfolio, and they thought that it pretty well nailed down a 2.5-inch drive, and they were going to try to put IBM out of business in the 2.5-inch drive area. And
yeah, they did try that. Connor did take that. That was a different patent, I think, that had the form factor, and he took that into court, sued WD. Everybody wanted $5 million initial licensing fee, then 5 or 10 cents royalty per. He was a real moneymaker, except that they took him to court and eventually beat him. So he lost on that score.
Yeah, well, the patent office likes to say you can't patent a ruler. So, trying to say it, we own the 2.5-inch form factor doesn't work in the patent office. So,
well, it worked for Rodime. Rodime got a bundle of money for the 3.5-inch patent.
Did they? Okay.
Yeah, IBM licensed from Rodime, and the theory is they did it to raise the bar for every other disk manufacturer, who would then have to pay money to Rodime. So it wasn't that they wanted the license; they wanted to prevent all of the smaller companies getting the patent licensed. Anyway, Rodime is now a gambling company, in case you didn't know.
No.
They wound up becoming Littlewoods, which is the biggest gambling company in the UK. So form factors do pay off.
Then, IBM then approached us one time at Integral, and said they wanted a license to our dynamic head loading patents, and I thought, great, we're gonna get a good revenue stream here, and so they had a businesswoman and about six lawyers all showed up, and they said, well, you're infringing you're infringing a whole bunch of our patents, and so you owe us all these millions of dollars because of that infringement. And I was thinking that we were going to make some money, and here they present me with a multi-million-dollar bill. Needless to say, I was livid, and I suggested to the lawyers that they should probably leave the room right then before my anger boiled over and I hurt one of them, and to see the scramble of lawyers trying to get out the door, elbowing each other out of the way was rather humorous. And eventually, we did work out over the months ahead. We worked out a deal where we paid very little in the front end, and then it was supposed to escalate up, and we were out of business before we had to pay much.
Okay. That was their normal tactic. They'd come in and say, we want your license. And by the way, here's what you owe us. And by the way, if we want it badly enough, we'll cross-license for free.
Well, and the patents that they quoted were, some of them were had to do with, data integrity and all that John Blagela covered, and there were some mechanical ones that I covered, but we found that their patents were kind of shaky. Some of the air recovery John found was basically had been just lifted out of textbooks and put in a patent. And so, we weren't very impressed with the IBM patents, and we sat down with them and explained it. They gave us 10 patents, and we said, we don't think any of these they're either, they don't apply to us, or they are, won't stand up the scrutiny of a trial. And they said, okay, that's fine. Here's 10 more. They said, how long do you want to do this?
Yeah.
And so and since John and I had spent an awful lot of time preparing a defense, we realized that they could grind us into the dust. So yeah. That was it.
Yeah. Can I take you back a little bit?
Yeah, surely.
I'd like to go back to Amkadine, because I remember something to do with CalComp in that time frame, and I've never been able to figure out what it was. Did you work with CalComp, or did they have dealings with you?
Sorry, it doesn't ring a bell.
Okay. CalComp was in Southern California, and they were making 2314 clones and such like. And I remember somewhere along the line that they had your fixed removable drive and also your fixed drive. They were bidding on some jobs. Might have been something Dave Cadato worked out with them.
Yeah. Sorry. Okay. Nothing comes up.
That clears that up. Okay.
Okay.
Now, the thing is that the Superdisk wasn't very successful, but it certainly created what I'd call a monumental mechanical problem. You had 4 disks rotating in synchronism, 4 actuators, reading.
No, one actuator.
Oh, one actuator?
It was one actuator with 4 arms.
Okay. So the read-write channels must have been interesting. And I know that Ivan was, let's say, he didn't succeed at ISS because his ideas were always bigger and non-IBM compatible than the company could do. But you must have overcome a large number of mechanical problems on that project, sure.
Oh yeah, it was, and Roy and I were the two mechanical engineers on it, and it was and Roy had endless great ideas on how to solve the different problems, and 128 heads, and and the base plate was this rather large, very heavy cast iron piece that we could only handle with a small crane. And anyway, it was quite a machine, and I worked with Roy on a servo track writer for it as well. So the Navy bought a number of them and just loved them because there was such a huge amount of data underneath one position of heads, and they were using it for something that would be similar to Google Maps today. They wanted to be able to zoom into any place in the world where there was trouble going on and be able to zoom in until they got down to the actual ships involved, and this apparently worked out very well for them. But storage had a real problem with disk drives. They were trying to get beyond tape drives. IBM had given them the whole market on tape drives when IBM exited, and the disk drives at storage. There was a read-write engineer from CDC. I think his name was Micah Gary, and he was using, I never was overly familiar with a read channel, but I heard he and Juan Rodriguez talk about pump and dump, which was apparently a tape drive technique for read channels, and he put that in the disk drive, and it was so sensitive to any imperfections, anything in the disk, that he couldn't stand it, and so he was forever berating the disk manufacturers to take out the aluminum oxide particles that were in the mud, and of course they're what made them durable. Yeah. And so once he got all of the I would call it gravel out of the disk, then it was just a gooey mess that the head stuck, just dove into and tore up. And so storage never could produce a reliable disk drive because of this read channel problem and the modification of disks to get the aluminum oxide particles out.
Ah, interesting story there.
Yeah.
Well, I don't remember anybody else having problems with the read channel because of the oxide. They just lived with it, put up with what they got.
Well, there was one young engineer there, Jim Hopper. He was a read-write guy, and he, I think he took like 3 printed circuit boards that were being used for the read channel, and he redid it all on about a half a board, and it worked just fine and read right through everything, and but nobody'd buy it off. So I think that Micah Gary spent more time in Juan's office than Jim Hopper did. So
okay, wow, yeah. lessons from the past. Now, looking at PrairieTek from an outside perspective, looking in, you hit the market with a bang, pretty much shocked everybody. Looked like a rocket rising, and then deviated from the double density to do a half height. And that delayed the double density because you first came in at 20. The 40 megabyte was, quote, announced quietly, and we were going to do it. But you seem to go off to do the half height. And I always figured there must have been a reason to do that, because that gap to get the full double density out led to Connor and everybody else jumping in, such that by the time you had the 40, Seagate was at finest was at 60. So can you give me a bit of background on how come you deviated to the half height?
Again, I'm kind of foggy on that. We'd have big product planning meetings, and I was only I had a technical team of including technicians and draftsmen, and everything. It was I don't know, 30 or 40 people, and we could basically turn out one design every year and a half. And I don't recall the discussions that led us to choose which one we were going to do, but I know that from that first patent, it was a little over the drive was a little oversized for the eventual form factor, and then we went ahead and did and I thought it was a 2-disc with a stamped steel base plate, and I thought it was a really dynamite design, but the HP guys just couldn't get it going.
Okay. Well, Bruno, you've got a lot of information in your own mind I'm sure, to talk about with the patent in this area, because this is your field. So I think I'll toss the ball into your court to pursue a little more.
Yeah, thanks, Dal. Yeah, so I went through quite a few of your patents. There's something you said, though, in this call, which I was not aware of, that Quantum had one of the early load-unload patents and kind of scooped you out of this invention. Could you say a little more on this?
Yeah, I think Moon was one of their engineers, but they had a guy who worked as a consultant, and I can't dredge up his name, but I spent a bunch of time with Moon, and I forget how I knew him, but and I was waxing eloquent on the benefits of dynamic head loading, and didn't realize how carefully he was paying attention. So he went back with this consultant, and they quickly filed a patent, and it had a lift tab, out at the extreme end of the suspension, and our initial approach on that on the 785 patent, it had a little button in the tooling hole, and we decided we eventually got to where we wanted to lift it out at the far end, but then the Quantum patent had the symmetry there. So then we spent a whole lot of time we patented and tried to tell everybody how important it was to have a slightly off-center lift tab, which was all just to get around Quantum's patent. But then, but you know, and Dave Brown and I had stayed in touch to a degree over the years, and this Moon was, you know, I somehow I forget what my connection to him was, but anyway, they eventually suggested that we do a cross licensing agreement, and we did it, and then we went back to the symmetrical tab on the far end of the suspension.
Yeah, I read about this non-symmetrical tab, and I was wondering why, why you had this, but now I understand. Yeah, that makes a lot of sense. Did Quantum try to get, because Quantum became Maxtor, right? And so
no,
did they ever?
No, I don't think that Quantum never merged with Maxtor, did they?
Or did they merge with Connor then? They merged with one of the two.
Well, they were associated with a was it Hitachi or one of the Japanese manufacturers who did all of their building.
That was Matsushita.
Matsushita.
Yeah, Panasonic Matsushita. Yeah.
Okay.
Yeah. So actually, it's kind of irrelevant in what I was going to ask. But did ever try to commercialize this patent to against IBM and the like?
Did whom?
Did Quantum try to commercialize and get licensed from IBM through that patent?
Well, they cross-licensed with us on the dynamic head loading, and they were the major supplier to Apple, and at the time, and Apple claimed they had a guy that who considered himself to be a disk drive expert. I've forgotten his name now, but he said dynamic head loading doesn't work, and he proved it by using one of these air bearing programs. And an engineer that worked for me, a guy named Bruce Emo, real sharp fellow, he looked at it, and he found that actually what they had done was they had not allowed the head to move. They had kept the head rigid in the program, and so that it was unable to adjust to the disk, and so they got, he proved that it would crash every time because if you locked it up, it wouldn't fly. But and I'm not sure if Quantum ever actually incorporated the dynamic head loading in any of their products or not.
Yeah, so I mean, I know a little bit about this because I was at Seagate, and then I moved to IBM in '98 when IBM had made the decision to move all the products, including the 3.5 multi platters, to dynamic load unload. And there was a lot of work which I was involved with to do, multiple disks. And so some questions I have for you is, I think you talked about 2 disks with the RAM and the dynamic load unload. Did you implement this to more than 2 disks?
I don't believe we did.
And some of the.
I think it was just. I think 2 disks was it, because we're trying to keep a real low profile and do the PCM CIA plug-in and all. So.
Right. Yeah. Some of the issues some of my team was working with is the differential thermal expansion of the ramp system compared to the disk system. And one is plastic, the other one is metal. And so, if the 10th disk, it's much higher than the ramp or vice versa, that creates all kinds of problems. So IBM was successful in implementing this dynamic load unload to multiple platters, which was a feast. But something I wanted to ask you also is, so there's the tab, there's the ramp, and there's the back EMF to park the heads. Did you mention that the back EMF invention is the sole invention of PrairieTek, and nobody else had done this before?
I believe so.
Yeah, so that was key. Yeah.
And by the way, on that dynamic head loading with IBM and the cross licensing, and we picked up some IBM drives, and 2.5 inch, and looked at them, and we noticed that there was this mounting pad for a ramp, but there was no ramp in it. So we realized that IBM was using a ramp in their manufacturing process, but they were not shipping it in the drive, which would have violated our patent.
I see.
And so, then when they decided to actually then implement it as a full dynamic load unload drive, that's when they approached us for the cross license.
Mm-hmm. Mm-hmm. And so the other thing that IBM did was to optimize the air bearing design for load unload versus CSS, contact start stop. Did you do any hardcore air bearing modeling to optimize the air bearing to dynamic load unload?
The fellow that did the heavy lifting on that was this guy Bruce Emo. Yeah, EMO, and he I know that he did air bearing work, and we saw, we had the results from Bougie, but I know that Bruce also did he did a whole lot of testing, and he determined that what some of the initial attitude parameters required for the head were to make it successfully land on the disk. And he figured out there were some aspects of the pitch and roll that that would cause failure, and so he did work out some initial conditions that were unfavorable for load unload, but I don't know that we modified the air bearing.
Right. And did PrairieTek or Integral ever put data on the landing area?
Did we ever do what?
Did you ever put data? Did you that landing zone?
Oh, did we put? Yeah.
Did you store data
in the landing zone
at the OD? Yeah.
It seems to me, you're asking me to try to remember things from 30 years ago or something.
And it's okay if you don't.
It seems to me that was a big discussion, and but I thought that we ended up, we did, I think that we did not put data there, but we managed to narrow up the landing zone smaller than a crash stop zone, so that we actually got more data on the OD than previously.
Right. Okay. Yeah, thanks. I have some other questions, Dal. Maybe I'll let you judge, but the question on the patent 171 micro miniature hard disk drive. So I don't know whether you're okay to talk about this now or later. Please, let me know.
Sure, let's pursue that one, because that that ties into HP and
Right. Right. Yeah. So Jim, this is the patent is 1995. I think the priority date is let's see, 91. So filed September 25th, 1991. So micro miniature hard disk drive. So, so this is you as the first inventor, David Ferre, Robert Alt, Bruce Emo that we talked about. And this is integral, right? Not PrairieTek. So could you talk a little bit about this? I was very intrigued because what you seem to describe in this patent is the Kitty Hawk, the 1.3-inch form factor with the the IDE connector on the side, which is exactly what the Kitty Hawk looks like. Could you talk about this?
Wow, I don't have a copy of that in front of me, and I'm kind of at a loss as to what. Yeah.
Okay. All right. Yeah. Yeah. Never mind. So this is again, this is form factor of just about 1.3 inch. You describe as 33 to 34 millimeters with a ramp load unload, and then the the ID connector on the side of the drive. If you don't recall, that's okay. I was intrigued because the time stamp of this patent just about corresponds to the start of HP's Kitty Hawk program in the early 91. And as you know, Kitty Hawk was a commercial failure, probably was a great technological feat, but a commercial failure. There was no market for 1.3-inch disk drive in the early 90s. And as you probably know, that was the kiss of death to HP's memory division. And they folded the whole Boise division from then. So, by the way,
let me give you a little aside here that of interest. My older brother is a PhD high energy physicist.
Yeah, Chuck.
Oh, you know him?
I was talking to some HP guys from HP Labs a couple of days ago, and I mentioned to them that we're going to talk to you and asking them whether the Morehouse in the HP Lab was related to you, and they said yes.
Yeah, that's my older brother.
Right.
And he came up with what he thought was a really dynamite formula for their disk recording media.
The thin film disk, yeah.
Yeah, and my brother has told me that he considers engineers are the technicians that implement the brilliant ideas of physicists, which I'm not sure that I agreed with him, but he came up with this great idea for what they should coat their disks with, and apparently it was a disaster from day one.
Interesting. And I think your brother went on to England, maybe.
After HP, let's see, I forget what he worked on CAT scanners for there was an outfit that built them in Palo Alto, I think. He worked on that.
Okay.
But yeah, he was in England, he was in Germany, but I thought that was before he got to HP.
Yeah, he went to Oxford University, materials department.
Oh, that may be. Yeah, I didn't track him all that closely, but
that's okay. Yeah, but yeah, congratulations. Yeah, a well-rounded family. So yeah, so Dal, thank you for prompting me. That's all the questions I had
Sure.
for now. So.
Well, Jim, some of the things that I don't know if you recognize or realize just how important your patent 7085 was, because I did some analysis for the of patents in general and their importance, and things like the majority of patents have no references. Nobody ever references. 6 is the most common number. Over 20 is significant. So if you've got a patent with 20 references, it's a pretty significant reference. Now, as of 2012, your patent 4933785 had 211. Now, that's right up there in premier company, by the way. The most popular is a battery by Union Carbide. So here's a little rinky-dink industry compared to the battery industry. And you've got 2/3 the number of patent references as the battery industry does. Now, just to like pour more oil on this, there are a number of classifications of a patent, and your patent covers 16 of them. So it's like pretty far reaching. So that's the background to why one of the criteria that Linus Connor recognized the breadth of your patent, if he could exercise those rights, would give him a stranglehold on the disk industry. Now, his strategy didn't work out, but he had the basis for a very good business plan to use that way.
And who the guy that was running the company was Bill
Allan, ex-IBM. Bill Allan was the guy at IBM who kicked off the Rochester division, and he wound up being so valuable to the people in Japan that after he retired from IBM, they had him on coming back to Japan to visit them because they thought the sun shone out of Bill Allan.
Well, he's the one. He was the one in the federal court house that was doing the bidding, and then sometime later, his son, who was Bill Ullman Jr., right? He was our marketing guy at Integral briefly.
Okay.
But we could just never get the sales to stick there. So
okay. Well,
I mean, we even were closing in on a big deal in Taiwan with our 1.8-inch drive. I'm pretty sure that was integral, and when they said, "Oh, your drive just died, it doesn't work," and we brought it back and looked at it, and someone had taken a large magnet and put it on the lid and destroyed the servo data. So there was a lot more to selling than just having a better mousetrap.
Oh yes, I'm sure Steve Vault's very aware of many of those things.
Yeah, but he was a good promoter, but I don't think he knew how to. He was not a finest conner.
Yeah, well, Steve came out of Tallgrass, which I remembered as the tape subsystem company. So he moved from being a value-added reseller, subsystem integrator, into basically the creative side of the industry. So he did a good move.
Yeah, but we didn't win.
Yeah. Now, one of the things that's kind of puzzled me. You remember falling in love with dynamic head loading because of somebody referencing it to you from a head company, which would probably be Applied Magnetics down in Goleta.
It was either Applied Magnetics or was it, what was the other, IO? There was another head company.
Yeah, but Applied Magnetics was the giant.
But no, there was another one that was just right behind them, and I thought it started with an I.
I'll have to check my notes. I'll take a look, see what I can find.
But anyway, yeah.
Well, the thing is that the first disk drives, removable disk drives, throwing the head out into the maelstrom was standard procedure. It was the only way to get the heads out there.
Yes.
And it's interesting that that kind of just disappeared when it came to the Winchester technology. And like you say, it took a head guy to remind you that that worked.
Yes. You know that when we were at Disk Systems Corporation, there was this kind of crazy little German guy, Herb Stollertz, and he was supposed to be our head expert, and he didn't have a lot of good practical sense, but he was a real busybody, and he somehow he went to the dump in San Jose and managed to get his hands on some Winchester heads that IBM was throwing out before they ever shipped a Winchester drive. And so he knew what the configuration was, but then he ended up insisting that the taper on the front should go 3/4 of the way back on the head, and it made a totally unstable air bearing. And I think that Roy Applequist overrode him and said, no, that doesn't make sense, and without doing an air bearing running an air bearing program, Roy just used his skull and just said, hey, got to make it longer and less taper, and they worked fairly well.
Well, back in those days, IBM used to sell all this scrap metal to Western Metals, and it was quite normal to send guys over to Western Metals on a weekly basis to check out what had come in. So
okay,
that's a completely believable story, because that was also one of the places where we picked up information when I was at ISS.
At storage, we were working on working with 3M. I think 3M mostly on the disks, but we nobody knew how IBM was lubricating the disks, and so one of the engineers that worked for me, I assigned him to try and figure all this out, and I think he ended up talking to like DuPont and figured out that it was liquid Teflon that they were using, but we tried spraying it on and tried all sorts of different ways, and nothing seemed to be working. And at some point he was talking to this engineer was talking to a company that made clean room compatible cloth, and he said, you could get these little square, 4-inch square cloths that we'd use in the lab, in the flow benches and all. and he's talking to this company, and he said, you know, they got on the subject of a roll of this cloth, and the salesman said, "Oh yeah, I sell tons of those to IBM." And we said, "Do tell." and you know, that after that, you know, I'd heard that IBM's suppliers often gave away the store, but so this engineer, Rick Altabellis was his name, he proceeded to build a lubrication machine, and you'd put a disc in it, it would spray I forget what was that stuff called, the lube.
Teflon.
Huh?
Which one? The Teflon?
Yeah, the liquid Teflon was.
So the one from DuPont is called Krytox. Is that the one?
Yeah, Krytox. That was it. Yeah, that's it. Yes, very good. And so it would spray that on with a solvent, and then these arms that come in with rollers and slowly move this cloth, so it was kind of fresh all the time, and with padded rollers, and burnish it into the disc, and so we ended up, as far as we could tell, we had duplicated IBM's process with the help of their supplier.
Yeah, that's interesting. I'm sure a lot of that went on. It was certainly a huge industry, basically trying to figure out what was IBM doing this month.
Yes.
It sometimes led people into a rat hole, because sometimes IBM pursued avenues that were unsuccessful, and companies which relied on that avenue also wound up, the company being unsuccessful, because they.
Well, you know, when Bill what did we say his name was? Junior?
Bill Alman, A-L-M-O-N.
Bill Alman, yeah, Bill Alman Jr. When I remember being in a product planning meeting with him, and you know, we said, well, you know, what do you want us to build? You know, here's 6 different things we could pursue. And he said, well, all of them. I need one of each. He said, that's what we did at IBM. We built everything and then took it out, and then we saw what people were going to buy, and then we would focus on that. And I said, well, yeah, but I don't happen to have IBM San Jose at my disposal. I've got just, 30 or 40 guys here that you got to choose one. And he said, can't do it. Got to have them all and then see what they bite. And he and I kind of were at loggerheads over that.
Wow. I can imagine the difficulty of an IBM executive leaving the company, going to a startup. They just did not understand the difficulty of working with one tool.
Yes.
They had so many at their disposal inside IBM that there was just a blanket. But when I was at IBM, we never felt like that. We thought we were working with the least amount of resources that you can have. So the contrast is rather, remarkable. And going back to the early 60s, I was on a design project for their intermediate multiprocessor. Now, we thought we were making brilliant breakthroughs. If somebody had given us a UNIVAC 1108 manual the day we started that project, we would have had it done in a quarter of the time. But honestly, we were just so narrowly focused that we didn't know anything of the outside world. And so that's why there had to be a lot of projects going on, because we never knew what was going on outside.
Okay.
So, and I think that's part of it. Um, NIH was enforced at IBM because we got no external knowledge. And that changed, of course, but the early 60s, it definitely was.
Well, I visited IBM San Jose a number of times, and and we actually bought discs from them for 2.5-inch discs for a while. They supplied us, which kind of surprised me, but yeah, they were happy to. The disc guys were happy to sell them.
Well, they did have difficulty. They wanted to be in the OEM market for disk drives, but were never willing to commit to the same level as other companies. So they would always feed their internal customer first. And that hurt them badly when it came to crunch time because there were always supply issues. Having to order 9, 12 months in advance for parts is a tough act. It's all based on forecasting, which is an imprecise art. When it came time for allocation, IBM fed IBM first, and that soured an awful lot of companies that wanted to do business with them.
Well, Tom Mitchell certainly was a spark plug for Seagate. Yes. He got them out in the market fast, really fast. Over multiple dead bodies, but
well, one of his dead bodies was Miniscribe. Did Terry ever tell you the story of what happened at Miniscribe?
Who was there?
Well, Terry Johnson.
Well, I know.
When he had Miniscribe.
Okay.
IBM was buying product from Seagate and Miniscribe, and they sent out a fax and said, "We've got too much. Stop shipping." And Terry believed the fax, and he stopped shipping. Seagate ignored the fax and kept shipping. IBM needed the drives, but because they were building a lot of product. But Terry took a severe hit, and that hurt him badly at Miniscribe.
Okay.
And that's a simplified story. The story is more complicated, but that's the essence of it, is that he believed the purchasing people, and Tom Mitchell said, screw them, ship anyway, and, inadvertently helped Seagate, but also hurt Miniscribe badly. Yeah, a lot of things happening like that.
And Syed went with down to Seagate, and I know that Roy was telling me one time about Syed had, let's see, they had a band on the stepper motor, and but it had a wheel there as well, and so it was redundant, or so not only was it trying to move because of the band, but there was this wheel rubbing on the band, and they had a little inspection hole that after they ran it for a number of a large number of cycles, they'd look in the little hole to see if the band had broken yet. And it was just, that Syed just, he wasn't a very practical guy. And he couldn't see that that he had this redundancy there where this wheel was fighting with the band and breaking the band. But they never changed it, but, they just tested for it. But, and I never looked at it all that closely, but Roy, he designed Terry's rack and pinion.
Yeah. Terry used Roy a lot.
Yep. Well, I used to I'd go out and visit Roy at his house and on the Russian River. Like every 6 months or every 6 or 12 months, I'd go out there and sit down with him and spend a bunch of time. And Terry encouraged me to do it, but I mean, I did it because I just loved Roy. And so, yeah, Roy and I were good buddies.
Well, when you mention Syed, it brings to mind that he had SideQuest, which was a miniature version of Arapaho. When you think of it, Amkadine was a removable fix, right? So you had the removable rigid disk long before Syed. And I would have thought you and Syed were kind of like compadres in that respect, but Syed was always insistent that he had the first removable hard disk drive.
Every time I saw him, he'd be, "Oh, Jimmy, my buddy Jimmy, he'd carry on, but he did okay for himself."
Yeah, he did work out. And another guy, you mentioned Juggy.
Yes.
Juggy's also had an oral history done, by the way.
And, okay.
And you might want to read it. Juggy's one of the more interesting people with stories about him. The one of those that I heard was that he never had any rejects, that every drive he put together shipped. But then I found out that what happened was, supposedly, everything that failed was taken back, broken down, and put back into the line, because the probability was that the next mix would work well enough to pass. And he was really an artist at being able to cost reduce a product.
Well, he was an interesting guy. Yeah. That reminded me that while I was at StorageTek, they brought in Steve Kazoos. You remember him?
Yeah.
And he was a flamboyant, interesting guy, smart, fun, neat guy. And then he went off and did his drive startup as well.
Yeah, I forget the name of that one. But yes. Yeah. Well, you've known a lot of interesting people and worked with. I mean,
yep.
I go back over the number of people that I've met over the years, the number of people who were significant in either marketing or on the engineering side, moving things forward. And you were right in there amongst all of them. So for a guy who went to Longmont, to Colorado, I should say, to save going to LA, you managed to make a good fist of it, I might say.
Yeah. They never hit the home run, but at least got a base hit.
Well, where did you decide to move into ranching? I mean, after PrairieTek, Integral Peripherals, you had a much longer run. But if you look at Wikipedia, you guys don't exist with Integral. There's nothing about them, which I find surprising because you've got a large number of patents at Integral. And the company has a large number of patents. You created a different variation on the industry. You pretty much did the PCMCIA thing with your disk size. And the company doesn't get mentioned on Wikipedia, which is a little unusual. There's always somebody with something. But you had a much longer run. And I liked your story that you got financing by selling licenses. It took you out of the realm of the VCs.
No, we started, Integral was funded by Taiwanese money, a guy named Chin Lin and some of his friends. But then as when our sales weren't up weren't maintaining us. That's when we started to sell licenses, and we kept going a couple more years with that. I think we may have raised 30 million or so through licensing, and we used to have classes where we would have the engineers from the companies that bought a license. They would come in, and we would then, besides the patent, my engineers would have classes on how the dynamic head loading worked, how the unloading worked, how all the various pieces worked.
Well, I must say that's novel. I thought that was definitely kept you out of the hands of the vultures.
Yeah, but temporarily.
Yeah, whole things work, and
the when I mentioned that that Integral got designed into that drive at IBM, or into that tablet computer for IBM Japan. And when it looked like it was very promising, then the Taiwanese came in, and Chin Lin said, I have some friends that want to buy some stock. And we said, well, we're actually, we don't need to raise any money. Our sales were enough to keep us going, and we hadn't started cross licensing yet. We said, we're good. And he said, no. He said, watch my lips. He said, I have some friends who want to buy some stock.
Okay.
And what they would do is they try to pick up a bunch of stock when they thought one of their investments was going to go public in a few months or a year or something. They wanted to pick it up really cheap, and then they would get 10 times their money when it went public. And he said, you will sell some stock. And we said, oh, okay. And so we rounded up the founders, and and we all pooled some of our stock together that we thought we were going to be selling on the in the market, that we were going to go public and make a lot of money. But we all pitched in some of our stock and sold that all to Chin Lin and his friends. And that's the only money I ever made off of disk drives. And otherwise, they how they say how to make a small fortune in cows.
Yeah.
Start with a large fortune.
Yeah.
But
that is so true.
I finally made some money off it.
Yeah, a lot of people went up with wallpaper with their stock certificates.
We had a graphics designer that Steve really liked, and one time he presented us, with rolls of toilet paper. Each one was stamped with one share of integral peripherals on every square of toilet paper.
If you still had a roll of that, it would make a lot of money on eBay.
It probably would, yeah.
That's a novel idea. Now, one of the other things that I did some numbers on the growth of the industry, the laptop industry, after you guys introduced the 2.5-inch drive. In fact, do you realize that the meeting at which PrairieTek, JVC, and Conrad Inc., you all had different sizes of disk drive? And Sun Microsystems called a meeting at which they needed tie it down to one size because there's no room for a cable inside a laptop. And that meeting is what spawned the SFF committee, because everybody who wasn't invited found out about it and yelled, "Hey, antitrust." And the month after that, Seagate hosted in San Jose the first meeting to discuss this new form factor. And out of that came the SFF committee. And it was a guy from Compaq who was the editor of the document. And everybody was niggling over millimeters here and there. And before his final draft went out, he told everybody that, well, he didn't care what everybody felt at the moment, but basically this would be attached to the next RPQ that went for a Compaq purchase of disk drives. At that point in time, full discussion ceased, and that was the form factor.
Okay.
Now, just the strange sequel to this is that 3 months later, after it passed, of course, in the ballot, guy from WD puts his hand up and says, "David, could you do a 3.5-inch form factor for us?" And that was the beginning of the form factor for 3.5-inch. So, that one meeting that, was hosted, I think you might have hosted it with Sun at the request of Sun Microsystems.
I don't recall being at any of those small form factor meetings.
You weren't. John Bagala was your man.
John, yeah.
But it was just that in the beginning, Sun Micro was building a laptop at the time, and they wanted to get the size fixed because they couldn't proceed with they eventually didn't ship the laptop, but they kicked off the whole thing about form factor being critical. There was no room for cables. And that's when disk drives went to being an interchangeable element.
Well, the Connor, Stefanski was one of their engineers, and in Glade, I forgot his last name, but they had a couple of designer guys that they were real good designers. They weren't engineers, but they were pretty good seat of the pants designers. And their first 2.5-inch, they did it with a snap together case. So it was a plastic case. And as soon as anybody tried to incorporate it into their laptop, the noise from the rest of the laptop was killing the disk drive. So they had to put it in I don't know if you remember, so their early drives were inside I think it was like a copper foil envelope to try and
yes,
yeah, to try and isolate it.
Yeah.
And then I think they eventually got rid of the plastic and went with metal.
Yeah, a lot of things happened then. Now, the thing in terms of revenue, let me look here and see. The laptop market blew out to the point where it became $1 billion industry almost within months. So that one product and such like, I don't think there's ever been an explosion of the kind that anywhere of how much significance there was in that providing an avenue for every PC manufacturer to create a new product, a new bank of products, And between the combination of megahertz changes on the chip and capacity changes on the disk drive, the market for laptops was a consumable. It was no longer a capital item because every 6 to 9 months, companies were buying new laptops for the latest performance. So pretty significant.
Well, you know, in the my experience on the integration of drives into laptops was that Japan to a degree and Taiwan to a huge degree, they would contract, they would design a laptop for generally for someone else, and then and put all the pieces together, and so they were not being designed in the U.S. They were being designed in Japan and Taiwan, or at least the assembly of into a laptop.
Yeah,
that was my impression.
Well, what happened was you had Zenith and Compaq were the market leaders, and they advanced every step of the way, moving along. And IBM was in there, and everybody was designing. And as you say, it turned into a turnkey operation where it was easier to subcontract a job to Taiwan, get the development, put the label on it, ship it, because it was turning over so quickly that any one company couldn't keep up with each market segment. So,
and the I was sitting at one of these get-togethers for the IDEMA, I think it was.
Yeah, that was Jim Porter's show.
And I was sitting at a table, and actually, I think it was my brother was sitting at a table nearby, and somehow or other it came up that we were getting our money out of Taiwan, and I made the comment, I didn't say Taiwan. I said our investor. I said, well, there's always a side deal to a side deal, and probably a side deal on top of that. And someone turned around and looked at me, and they said, oh, you're dealing with the Taiwanese?
Yeah. By the way, question. This comes back to naming. And Integral, you had Mustangs and Mavericks, right?
Yeah.
Was that Ford or Western influenced?
Was it which?
Ford. Ford sold Mustangs and Mavericks. It's also a Western term, Mavericks for cows and Mustangs for horses.
I think that Steve probably came up with them.
Okay.
I was in engineering.
You were buried elsewhere.
Yeah, I was.
You wound up with horses, right? So you have yourself a horse ranch.
Yes. I did manage to get up to 18 horses at one point, most of them Clydesdales, but we're down to 6 now.
Okay. You like them big.
They are nice. They're gentle giants. They're really wonderful horses.
So when did you buy the ranch?
Late 90s. Yeah, after I left. But we had horses for 20 or more years before that. Every one of our vacations, my kids never got to go to Disneyland. All we'd ever do was we'd load up a bunch of horses. They'd each have a horse to ride, and we'd have a couple horses as pack animals, and we'd take off into the wilderness areas and spend 2 weeks wandering around in Colorado wilderness areas.
Wow. Well, that does sound idyllic.
They grew up to be pretty independent, self-sufficient.
So basically, you just got out of the game after Integral.
Well, except for the, I came back in for that one, that expert witness in Seagate versus Connor.
Okay.
Conus.
All right.
Cornice.
Now, so I guess looking back, I've done a lot of talking about that one patent. But if you look back, what do you see as your most important accomplishments?
Well, you know, these patents end up being referencing previous patents and then bringing in a few more ideas, and it kind of, they kind of grow and grow, and so the four things that I mentioned earlier, which was dynamic head loading, the let's see, dynamic head loading, the unload with using the back EMF on loss of power, run out compensation, and although that was Tom's baby, and the eye lock, I thought were the big contributions.
Okay. Bruno, have you got any thoughts there on what you'd like to compliment?
Yeah, run out compensation is, and I forgot to mention it when I was asking you a question, but that's also something that all the companies are doing today, which is remarkable. I also noticed that you very early on, probably earlier than what Seagate did when I was there, look at how the disk is clamped on the motor, and how the clamp mechanics affects the distortion of the disk. And I think one of your patents is using some type of viscoelastic material at the clamp zone so that the disk is much flatter. Do you remember those, and could you comment on those?
Yes, I at PrairieTek, I designed a threaded ring as a clamp, and that allowed the motor to be a little higher. And I looked into it at great length, and it was actually a very viable approach to disk clamping. Unfortunately, when we tried to build some pre-production runs there in Longmont, the HP engineer that was he was, I forget what his title was, but rather than work with me on perfecting the threaded ring, he just signed anything that came in, signed it off and sent it to the line. And so we had very rough surface finishes on the threads. And so that threaded ring didn't work out. And let me take an aside here, and then we'll get back to your question about the plastic clamp. So when I was designing that motor for the 2.5-inch drive, I went back and I got an engineer that had from this tape drive capstan motor company to help me work on the design. And and I did a rough prototype and proof of concept. Then I took it to a small company in Tokyo, and they built a couple of them for us. And then I took that one of those motors. I had it in my pocket, and I went down to visit NIDAC. And you know, have you ever dealt with the Japanese?
I work for Hitachi, yeah. So
okay, and you know, I go into this room, and there's 8 or 10 engineers all on the far side of the table, all lined up by age. And the oldest guy is across from me, and then it goes down to the youngest fellow, and I can't remember the name of the senior guy, but he was a wonderful fellow that he and I ended up very friendly for years. But he we sat down, and the room was freezing, as they like to run their conference rooms, and a little tea and a little chit chat, and then he finally says, Dr. Morehouse, we have looked at your specifications, and we have decided that it cannot be built. And since the whole company was based on getting this motor built, sorry about that, the phone. So I sat there looking across the table at him, and I finally reached in my pocket and I pulled one of these motors that had been made in Tokyo by a kind of a prototype shop. It was very nicely done. I set it in the middle of the table, and I said, "Can you test this?" Which, I mean, I knew very well they could. And he said, "Yes, we can test it." And they passed it down, all the way down to the youngest guy at the end of the table, who then disappeared. And then we sat there staring at each other for 20 minutes. And then the young fellow came back in, and with a sheaf of papers and the motor, passed it all the way up the row to the senior guy. And we sat there for a few minutes, nothing being said. He's looking at the papers, and nothing being said. Finally, I said, "What were the results?" And he said, "The results were agreed with your specifications." He said, "We should be able to build it. Let us proceed." And I was a bit relieved at that point.
Great story. But so, did they measure runout, or what did they measure?
Oh, they measured the back EMF.
Oh, the back EMF.
That told them everything about the resistance and the back EMF. They knew the motor. Yes. So, to go to your question about the plastic clip-on, that was the brainchild of Jim Dunkley, mechanical engineer, and he came from Peterbilt, and I hired several guys from Peterbilt, and figured, they knew about round things spinning, and wheels on trucks and all, so they ought to be able to work on disk drives. But Jim, he was a real good engineer. He and I kind of constantly butted heads because I'm a mechanical engineer, and he thought that I helped him too much. And I tried like hell to stay out of his way, but he still thought that I was giving him too much help. But he came up with this idea of this snap-on, rather than clamp it, just snap it there on the hub. And I was, I had been clamping discs down on motors for so long that it just didn't seem to me to be the way to go. But he was really enamored with it, and I figured, I need to keep my hands off, so I let him run with it. And at that time, Tom Andrews, the servo guy, had perfected his run-out compensation, so it didn't really matter if it was perfectly centered or if it shifted, because it could. I forget how often it did the fast Fourier, but it could maybe every time on spin up, or every so often would do it. So if the thing did shift or move around, that the servo could take care of that, and so we did use that.
Okay.
At least for a while. I forget whether it was in everything we did or not. But
thanks. And then perhaps the last question, Dal, if I may. Something you said, Jim, that piqued my attention. You mentioned Professor David Bougie at Berkeley. It's funny you mentioned him because a couple of weeks ago, maybe a month ago, he celebrated his career, and he invited all of his former students and some of the academic people, as well as a few industry people. And I was lucky enough to be invited because I've worked with him quite a bit myself. So yeah, it's interesting that you mentioned him. And I know that he and Professor Talkie at San Diego, I don't know if you know him. He used to work at IBM, and that's how he got to work with David Bougie when Professor Talkie was at IBM in San Jose. So they actually they championed the use of laser Doppler vibrometer, LDV, to look at slider dynamics as well as all dynamics in a disk drive. So when you mentioned that you had some help from him to look at the slider dynamics doing ramp load unload, I was interested to know maybe a little more. Did you have a formal collaboration with David in Berkeley?
Well, first of all, I ran across one of his papers that showed where he used that interferometer and showed how the head settled down and landed beautifully on the disk. Mm-hmm. And I used to put a slide of that up whenever I gave a talk. It was sort of my favorite go-to. And so after I became familiar with that paper, I went and met him, and we never, I don't think, well, yes, we had a certain amount of business together, and I think I provided him with a large number of disk drives for him to because he had some problem of procuring what he needed, and so I gave him a bunch of stuff, and we got along quite well. I thought that he was one of the only academic people who ever really contributed to industry. Right. In general, I thought that, like you said, at IBM, you were so narrowly focused that, and I thought that universities were, never got far enough down the road to help industry. And so we didn't use them much. Mm-hmm. I went back to Berkeley on recruiting trips, to try and find engineers. But I also then met with Bougie on several occasions.
Okay. Yeah, he had the CML Center for Computer Mechanics Lab.
Yes.
And so he was sponsored at the height of the center. He had up to, I think, 24 or 28 companies sponsoring him. He was down to 2, I think, last year, and he's pretty much winding down this center now, which is a little bit sad, of course. But he had a great career, and we celebrated his career, like I said, a month ago, and it was great. So, yeah, it's good to hear that you've known him and appreciated his input to the industry. So thanks. Dal?
Yeah. Uh, Jim, coming back to it, you've mentioned two events that basically transformed, for want of a better term, your life in the sense that one was Dave Brown getting you into Memorex. The second one was StorageTek talking you into going to Colorado. Would that be a fair assessment of the transition points in your life?
Well, you passed over one in 1969. I asked the wonderful lady to be my wife.
Okay.
And she accepted. And a friend of mine told me that was probably the best thing that ever happened to me in my whole life. And we are still happily married after 54 years. And and three wonderful kids.
Well, I track you on that one. I did mine in 64 and we're still there.
Well, very good.
Yeah. So yeah, no stories to tell about.
Well, and my oldest son, by the way, is a general, brigadier general. Yeah.
He was in the Colorado Reserve. I remember reading about him some at one time. Yeah.
He's in the National Guard, the Colorado National Guard, and he's basically assigned to the Space Command Center in Colorado Springs. So,
yeah,
and he can't tell me anything that he does.
Yeah. Well, that's a mixed bag, isn't it?
Yeah.
So, looking back, and this is a question that CHM is interested in hearing from the orals, is that if you could change or redo any event or decision, what would it be?
Well, I thought that my team designed a lot of really good products over the years. And I felt that where we fell down was in sales and marketing. Finance went down to Compaq, and even with a drive that John Squires put together, and it had flaws. Let's say it was not perfect, but finance managed to keep them in there, and they bought everything that they could ever build. And so to me, finance was the ultimate salesman, because he could make a sale and make it stick, and we just never could. And so I thought that and people always they say, oh, I've got this great idea, I think I'll patent it, and I say, well, that doesn't get you very far, except you can pour a lot of money into it and not get anything back. But to me, and maybe it's because I'm not in sales and marketing, but to me that was our big failure.
Yes, I think you nailed it in one, because from the outside looking in, once again, I was never close to you guys in Colorado because I was here in California. But there were decisions made that redirected the company, and they were dead ends. And it only takes one bad decision to start in the wrong direction, and then that kind of catapults and rolls on and causes other ones, because that story is relatively common in the startups here in California. I could name you several key events in individual companies where one decision to pursue one contract or one this or one that, which poured all the resources into one place, and they failed. Or worse, and I'm not sure which, I shouldn't say worse, a different scenario is, oh, we need a backup plan. So let's dilute all our resources to have an alternative. So there's two courses here. And I think there's more than an element of luck, but there's definitely, as you said, the art of the sale and the ability to convince others that yours is the best or yours is the right one is key to a successful company in a game which our industry was. We had so many companies springing up, all competing for the same prize, all with talented people, all with workable products, differences between them, but all possibly viable, but only one or two ever made it. So, yeah, it's really a difficult game, isn't it? Technology and ability is not enough.
And even quantum, they were very successful for a number of years, and then they just slowly went away.
Yeah. And your other story about bringing in a bunch of people who didn't know how to guide the company, you can look at Maxtor as another example. When they went from having disk management to semiconductor management, and the company's trajectory stalled. And eventually they came back and were acquired, but there's a lot of stories around that as well. So when you mentioned the influx of management who could not make the right decisions to get you guys into a position where you could succeed is also a familiar one. So you've been through it.
Oh, yeah.
And I have to, your story about your son being a general, I doubt that was advice you gave him.
No. One time I said to him, he actually joined the reserves, Army Reserves in high school, and he was associated with the military ever since. And sometime full time, and then he retired from the Army and got into Virginia National Guard, then moved back to Colorado and got in the Colorado National Guard. But I said to him one time, I said, "Gee, son, if I'd got you into Boy Scouts and and maybe got you a uniform and all that stuff early on, I said maybe would that have taken care of this craving you had for the uniform?" And he laughed and he said, "Well," he said, "I grew up running through the woods, carrying a rifle, running through the woods with a pack on my back." And he said, "And now I get paid for it." So, and then he said, and then he gets serious and he says, "Actually," he said, "I think this is such a great country." He said, I really feel good about giving something back to this country."
Well, that must have made you feel very warm.
It does, yeah. Yeah.
Well, in light of that, this next question is going to be kind of humorous, which is, what advice would you give to a young person starting out on their career?
I guess the thing that I would say was do some research into what areas of the economy are growing rapidly, and then see how you might fit into that. getting a degree in philosophy is not much of a promising career. Certainly technical careers are more lucrative. I know that Roy Applequist told me that when he first showed up at IBM in the 50s, that he ran into an IBM engineer who said, "Oh, you're new here. What do you do?" And he said, "Well," Roy said, "I'm a mechanical engineer." And this guy said, "Oh, that's too bad." He said, "You guys are obsolete." He said, "Everything's going to electronics. You don't need mechanical engineers anymore." And Roy stayed pretty busy for his whole life.
Yeah.
And I even managed and I had John Blagela as my right hand man for all the electrical stuff, and I tried to get the mechanics done. But find out where to go. And I think today code seems to be where everything's going.
Yes.
Writing code.
Yes.
And you did, I think somewhere I saw on your list of questions was, when did you write your first program, and where and how did it go? And I wrote my first program at Berkeley, and it was Fortran. And you go down and do the punch cards, and then submit a stack of cards to the computer center, and then come back a day later and find that it failed. And you'd make the syntax corrections and run it again, and it'd fail. And all my time, I did write one program one time that ran the first time, but it was really short and simple. But otherwise, it was a constant battle with getting it right.
Yeah. I think you wrote those questions must have had a background in software, because very definitely, I know that one of the possibilities I had at IBM, because I came out of a software background out of back east, and we had software development in IBM San Jose as well. And one possibility was transferring to engineering to get into microcode. And that was, at the time, I had no idea just how big that particular part would explode, to the point where disk drives practically, run on microcode. The microcode is compensating for mechanical this, mechanical that, temperature this, temperature that. It has become, the role.
I think that John told me that that our little integral drive had 80,000 lines of code in it.
Yeah, I believe it. Even then, it's certainly been a mushrooming industry for careers in this microcode, in which you have to be an engineer, a mechanical engineer as well, in order to write the microcode to control the mechanics.
Yep.
Yeah. Now, another question on this list is, do you think computing history is important?
Oh, I've always been a fan of history. I used to read history, on the ancient Egypt and Search for the Nile, and I read all kinds of history. So I appreciate history, and I think you need to know history in order to know where you're going in the future.
Right. And if you think about it, we've been talking about history today. We're looking,
Yep.
we're looking at an industry which started in the 50s. And you knew Roy Upperquist, for example, who worked on the Ramac. In one generation or two generations, perhaps, we've actually lived through an entire industry, because we're now into the point where we can see the end of the mechanical disk drive being replaced by the semiconductor disk drive. It's moving that way. So if you look at it in the arc of your career, in mine and Bruno's, we've actually seen an industry go from zero to a huge industry with 3 players.
Who do you consider the 3 players now?
We've got Toshiba is still in the game, along with Seagate and Western Digital. And that's rotating disks.
Okay, I think we sold licenses to all 3 of those.
Yes, you did. So, Bruno, is that the way you're seeing things too?
Yeah. I mean, I came to the game a little later than you guys did, right? But I saw the peak of the industry in the mid 90s or so, when the density, the aerial density would double every year. And then I left the industry 8 years ago, when the progress were single digit in aerial density a year. So I went from 40% to 100% down to 7 or 8%, and it's been great to witness this, and it's been great to be part of it. And I really thank you, Jim, for your input and your seminal inventions that have really helped the industry as a whole. So thanks very much.
Well, the transition to memory drives as opposed to disk drives, that it seemed that the disk drives had a cost advantage of 2 to 1 over the semiconductor memory, but the semiconductors are more rugged and probably more reliable long term. So it may be that disk drives are going to slowly go away.
Yeah, it's possible. And when I was at IBM and we were looking at the price of flash versus the price of HDD at the time, maybe 15 years ago, it was a 10x cheaper for HDDs, and it became 5x cheaper, and now it's 3x cheaper. So the difference is slowly shrinking. Now the HDD has introduced this new technology called heat-assisted magnetic recording. I don't know if you've followed that, and Seagate is now shipping drives, which with this new technology perhaps could increase density again. And so Seagate is shipping 30 terabyte disk drives on 10 disks, which is pretty amazing, 3 terabyte per disk. And now they're talking about a roadmap to 40, 50, 60 terabytes. So if this heat-assisted magnetic recording works and delivers, perhaps that will give us again, another 5-10 years runway for the spinning disks. But who knows? Maybe flash will also catch up. Flash now has multi-layer flash, right? And so we'll see. I still think that HDD has another 5-10 years, but could be wrong.
Well, I think it may be a little bit like electric cars. They're up and coming, but the internal combustion engine is going to be around for a long time.
Yeah.
So, yeah. So the hard drives will probably hang in there one way or another for a long time as well.
Yeah. Hopefully, we'll see.
Well, Jim, is there anything else you'd like to add or consider including in this?
No, I think I made a few notes to try and make sure that I didn't have a senior moment and couldn't remember somebody's name or a company name or something. But I think I covered about all of my notes, and I did you get all of your questions answered?
Certainly, I think one of the most important things is that the purpose of this oral history is to get back, what was it that, and the circumstances around which decisions were made that affected the industry. And you've given us a very good perspective on how you approach things, because you said one idea attracted you, really got your interest way back when, dynamic loading, and you rode that horse and you kept improving its, genetics, so to speak, all the way through. So it's not a fixation so much as a development classification in which you made yourself the one to follow.
Of course, then I would be assigned to go out and give my little presentations, at IDEMA or some such, and and so then I'd get invited, and they'd say, "Oh, what do you want to talk about?" And I said, "Dynamic head loading," and and I remember the moderator saying, "No, you did that last year, Jim. You got to come up with something new." And so then I think I modified it to say, well, use dynamic head loading to eliminate the shorting the head out problem on the disk. When the early MR heads were being zapped by because they were sitting, the element was so close to the disk. And that's why I believe IBM was doing the dynamic head loading during manufacturing, but then they went to it full time, and but so anyway, I modified my little talk to say, oh well, it's really good for building disk drives too.
Okay, well, I'd like to say on behalf of Bruno and myself and the History Museum, many thanks for sharing your time with us today.
Well, it was a pleasure, and it was real nice to see you once again and to meet Bruno.
All right. Thank you.
And fun memories.
Yes, indeed. Lots to remember.
You bet.
Bye now.
Thank you.
Bye, Bruno.
Bye.